All right, so we just wrote out this super long electron configuration for lanthanum. I don't know about y'all, but this is a lot of information to look at. It is very detailed. However, there are situations where we might not need all of this initial information and really are just focused on the stuff that is sort of unique to lanthanum. And we'll see what I mean here in just a second. So, long story short, we are going to learn a shorter way to write this same information. It's something called noble gas configuration. You might remember from the 8th grade that the noble gases are this block or family of elements here on the edge of the periodic table. I'll highlight them in yellow. And they're special for a few reasons. We don't really need to know why right now. But basically, they have full orbitals on the outside. So their principal or highest energy level and orbital are completely filled with electrons. So, for example, the p sublevel for neon is completely filled up with all 6 electrons that sublevel can hold. Anyways, the reason that we need to look at these noble gases is we can use them as an easy way to summarize information from the beginning of these electron configurations. For example, lanthanum. We wrote out all this stuff. What if instead of doing that, we used the most recent noble gas, which if we trace back very carefully, is xenon, and we said that all of the stuff from xenon forward, so that's before the 6 here, all of this information right here that I'm about to put in a box, one second. All of this we could just write as xenon, because a xenon atom will have that same configuration, right? It will have the same electron configuration that is written here. So if I really needed this information, I could go look up the electron configuration for xenon and find it. Then I just have this leftover information that is kind of unique to lanthanum or is not easily represented with this noble gas stuff. So we would still write that on. We would still put in our 6s2 and our 4f. You can do this for really any element except for hydrogen, since it comes before the very first noble gas. So obviously you can't use a noble gas configuration for hydrogen, but for any other element, you can find the most recent noble gas, put it in brackets, and then write the electron configuration for the tiles that come after it. So let's look at a second example here. Something much lower on the table. Let's say I just wanted to write the electron configuration for beryllium in noble gas notation. Now, beryllium isn't a hard one to write out in its entirety in the long way, but we can still use noble gas notation if we really wanted to. Trace back, and the most recent noble gas is helium. So in brackets, I will write helium. Then I will count over. I'm in the 2s, and then I need 1, 2 electrons in that orbital. And that's how I would write beryllium's configuration in the noble gas formation.